Good morning, student. Today we will study the distribution of oceans and the continents. As we know that the continent on which all the terrestrial life exists occupies only one third of its surface area of the world, and the rest of its area are occupied by vast stretch of oceans. Look at the map of the world on the screen. The position of continents and the oceans were not the same in the past as of today, and they are not going to be same in the coming future. The position of the continents and the oceans never been static or constant. It's ever changing, it's dynamic, it's changing every day, it's changing at every point of time since its formation. Many more questions might have erupted in your mind regarding this fact, like what were the position in the past, how they are changing their position, at what rate they are changing their position, why this so happens, how do scientists knew about its earlier position. All sorts of your questions will get answered in this following sections of this chapter. Now, observe the shape of coastline of Atlantic Ocean, and you will be very surprised by the symmetry of the coastline on the other side of Atlantic Ocean. If we join together all the three land masses of North America, South America and Africa together, they will easily fit into another. And this sorts of possibility of joining together of North America, South America and Africa was considered by many scientists. Among them was the Antonio Pellegrini. He drew the map showing the three continents together. You can see here, but it was rejected by most of the people. It was Alfred Wegener who came with comprehensive theory regarding the distribution of oceans and the continents, and he presented his theory in 1912 AD. The continental drift theory suggests that all the 7 continents, as you see on the map of the world, were once joined together in a single landmass called Pangaea or the supercontinent, and the Pangaea was surrounded by vast expanse of oceans named Panthalissa. Now come to the main page of continental drift theory. Actually, it was the hypothesis presented by the Alfred Wegener, and according to this hypothesis, there was a gigantic supercontinent 200 million years ago, and he named that gigantic continent as the Pangaea, means all earth. And the first split that began around 170 million years ago, that created two smaller supercontinent. The northern part, the continent was named Laurasia, and the southern part of the Pangaea was named Gondwana land. India is the part of Gondwana land along with Africa, South America, Australia and Antarctica. And the Laurasia comprises of North America and Eurasia. We can better study this continental drift theory through chart. You can see here the Pangaea is splitted around 170 million years ago. That created the two separate small supercontinent. First one is Laurasia, comprised of two continent, North America and Eurasia. The second division of Pangaea, second split of Pangaea, that is the Gondwana land, that was again splitted, leads to the formation of three separate land blocks or three separate continents named India, Africa and South America together, Antarctica and Australia together, Antarctica and Australia was separated around 55 million years ago, and the South America and Africa was separated around 124 million years ago. Now we will study the evidences which supporting the continental drift theory. The Alfred Wegener made certain evidences to prove that the continents and the oceans are drifting from its places. That evidences are the fit of the continents, similarity of fossils in the continents, similarity of rock types and the age of the rocks formation along the matching coastline, the continuity of geologic feature from the continent to continent, the presence of coal seams in the Antarctica and tillites. These are the evidences which we will study separately in the later slide. Now you can see on the left side of this world map, you can find there is a Pangaea, there is a super continent named Pangaea. You can see here the part of the continent which existed on the Pangaea. The first evidence in support of the continental drift theory was evidences from the landforms. If you join together all the three continents together, they will easily fit into another. Look at here, they are easily fit into another. All these three continents of North America, South America and Africa. This was a jigsaw puzzle. The second evidence in support of continental drift theory was similarity of fossils in different continents. One such fossil was the skeletons of the Mesosaurus. Mesosaurus was a small reptiles which survives on the shallow brackish water, were found on the coast of eastern South America and on the South African coast. This suggests that these land masses were once joined together. Another such fossil was the lemurs, the observations of the lemurs in the India, Madagascar and Africa, which says that these lemurs were living on the single landmass area, which supports the unification of all the supercontinents you can see here through different slides. The fossils are the traces and remains of organisms that lived in prehistoric times that are preserved. That fossils are helped they are helping us in knowing the different facts of the histories. Next evidence is the climatic evidence. The two evidences which are puzzling in the mind of scientists are, first one is the glacial traces or glacial deposits which are found near the equatorial areas. How could it be possible? How can it would be possible? Because the equatorial area are known for high temperature, but the glacial deposit can only occur on the polar areas. And the fossil palm trees in Greenland. The palm tree, as we know that, is the tree of tropical areas. But how can it be found on the Greenland, which lies on the polar north pole areas? How can it be possible? that palm trees, which is the tropical tree, can be found in the polar areas. Next evidence is the tillites. Tillites are the sedimentary rocks which are deposited by the actions of the glaciers. Now look at the glacier which are falling from the mountainous area and depositing at the base of valley. On the extreme right side of this picture shows the tillites or the tills which are deposited by the glacier. You can see the age of the tillites. These tillites of same age were found in Africa, South America, India and Australia. This suggests that all these 4 different landmasses were once joined together. Next evidence which supports the continental drift theory is geologic evidences. Rocks of the same age and the types are found on the coastal areas of Southern America and the western coastal area of the Africa. You can see the mineral composition, the chemical composition and the age of formation of rocks are similar over the coastline of South America and the Africa. And if you join the North American continent with the Europe, you can see the Appalachian mountain which is running on the northeastern part of America will join the Scandinavian countries in the single line, and the Scandinavian countries represents the country of Norway, Sweden and Finland of the Europe. And the glacial deposits are found in the Antarctica, South America and India were of same age, and now they are thousands of kilometers apart from each other. Now see, now what leads to the drifting of the continents and oceans? Now the question arises, what leads to the drifting of continents and ocean? For this answer, the Wegener suggested that there are 2 forces which are responsible for drifting of the continents and the ocean. First one is polar flying force, which are the result of rotation of the earth. You can see here on the map of world, the bulging of the central part of the earth is due to the rotation of the earth. And the second force which were responsible for the drifting of oceans and the continents are tidal force. Tidal force are basically the gravitational pull exerted by moons and sun. He believed that these forces became effective after a long period, that is millions of years of continuous exerting force. But these sorts of explanation by the Wegener for the continental drift theory was not accepted by majority of the scientists. Basically, the Wegener's theory was based on the evidences collected from continental areas only, like the fossils, different rocks, tillites. These were all collected from the continental areas only. After the First World War, deep mapping of the ocean floor paved the new dimensions for the study of distribution of continents and oceans. One such theory was given by the Arthur Holmes in 1930s, that is convectional current theory. You can see here convectional current theory. He explained the force issues that was lacking in the continental drift theory of the Wegener. He explained the force issues related to the movement of oceans and continents. He proposed that the convectional current, that is the current of molten material which was created by the differential heating in whole of the mantle portion of the earth, exerting forces for drifting of continents and oceans. Now you look at the picture here, you can see here this red position or the saffron color position represents the mantle portion of the earth, that is also called asthenosphere. Asthenosphere, the liquid portion of the earth or liquid portion of or molten portion of the earth material that is moving in the circular pattern, and these convectional currents, these are the convectional current which is rotating in the circular manner. This creates movement of continents and the oceans. You can see through graph the ocean floor configuration. You can see here continental shelf distributed over the sea. Second one is the continental slope, and this as third one is the ocean basin floor. We can study in the separate slide here. You can see here some of the features of the oceans here: abyssal plain, continental rise, submarine canyon, shorelines, continental slope, continental shelf, and the coastal plain. And there is another maps through which we can easily understand the different landforms of the ocean. And the middle portion of this map occupied by mid-ocean ridge, abyssal plains, abyssal hills. You can see the continental rise, submarine canyon along the continental slope, and that continental shelf, seamount, trench, volcanic island. These are the features or reliefs of the ocean topography. These are again, this is another map you can see here. The middle portion is occupied by mid-oceanic ridge, some are volcanic islands, volcanic mount, continental slope, continental shelf. The reliefs of the ocean floor are divided into three parts. First one is continental margin, second one is deep ocean basins, and third one is the mid-ocean ridges. Continental margin comprises of continental shelf, continental slope, continental rise, submarine canyon, trench. The continental shelf you can see here is the extension of continental plates. It varies in width, and the continental slope is the area which starts from continental shelf. The slope of this uh, continental shelf becomes steep. Submarine canyon, these are the erosional features found over the continental slope area. You can see here, this is the submarine canyon. These are erosional features over the continental slope. Next is the continental rise. Continental rise is also the part of continental margin. These are found in the transition zone between continental slope and the deep ocean floor. Next comes is the deep sea basin. Deep sea basin is also termed as abyssal plain. These are extensive plains, and these deep sea floor areas are very vast in size, and the sediments which cover this are varying with thickness. The next relief under the ocean floor is mid-ocean ridge. Mid-ocean ridge are the submerged mountain which formed at the margin of diverging plate boundaries. You can see here. The next one is sea mountains, sea mounts. Sea mounts are the submerged volcanoes and hills. When these volcano or hills becomes eroded and becomes flat, that volcanoes are termed as guyotts. There is another picture. You can see here the different relief features of the ocean. You can see here abyssal plain, mid-oceanic ridge, continental shelf, submarine canyon, continental slope, continental rise, transform fault, seamounts, trench, guyotts. Now come to the distribution of earthquakes and the volcanoes. You can see here over the Atlantic Ocean there is a long vertical lines of dots which again bifurcates into two parts. One part is moving eastward through Africa, the southern part of India, southern part of Australia. It again, this is an unbroken chain of dots, and these coincides with the mid-ocean ridges. These dots coincides with the mid-oceanic ridges. And the second one is the shaded portion of the dots. Shaded portion of dots represents the alpine mountain system. You can found this shaded portion over Himalaya and also around the rim of Pacific Ocean. The focus of the earthquake over the shaded portion is very deep, while the focus of earthquake over the dots in the middle of part of the ocean are very shallow, or the focus of the, you can see in another word, the focus of the earthquake over the region of mid-oceanic ridges are very shallow. Now we will study the sea floor spreading. The mapping of the oceanic floor and paleomagnetic studies of the rocks reveals the many facts. Among the many facts, one such fact is the volcanic eruption on mid-oceanic ridges outpours a huge quantity of lava in its surrounding areas. The second fact is the rocks equidistant from the crest of mid-oceanic ridges. You can see here. You can see here the rocks equidistant from the crest of mid-oceanic ridge shows remarkable similarities in terms of chemical compositions, the age of formation of rocks or mineral compositions. The age of rocks increases as one moves away from the crest. The third one is the oceanic crust rocks which are much younger than the rocks of continental areas. The next fact is the sediments of the abyssal plain is very thin, which is very puzzling again for the scientists. These are not as old as, or these are not older beyond 200 million years. And the next fact is the focus of earthquake in the trench areas are very deep, and you can see the trends are found along the coastline area. The focus of earthquake in the trench are very deep, while the focus of earthquake in the mid-oceanic ridge are very shallow. Harry Hess proposed that the continuous outpouring of lava causing rupture, here you can see here, the continuous outpouring of lava causing rupture in the oceanic crust and pushing it on the either side, and this results into the spreading of ocean, and the spreading of ocean doesn't cause consumption of the plate or destruction of plate on the opposite side. Oceanic plates sinks on the trench, and we will study the trench in the later part of this slide. Now we will study the plate tectonic theory. This is very recent theory which explains the distribution of oceans and the continents better than the any other theory. According to plate tectonic theory, the lithosphere or the solid part of the earth are broken into numerous pieces and that are termed as the plates. And there are two types of plates. One is oceanic plate, second one is continental plates. The thickness of oceanic plate is varying from 5 to 100 kilometer, and the thickness of continental plate is around 200 kilometer. Just below 200 kilometer lies the magma chamber, or you can say the asthenosphere, where the earth's material are formed into molten states. Plate constantly moving throughout the history, not the continents as suggested by the Wegener. Actually, according to Wegener, it was the continent that drifted through different geological period of time. But according to the plate tectonic theory, it is the plate, and the continent is the part of plate, and the continent lies on the plate that moved. There are 7 major plates recognized on the surface of Earth and some minor plates. The major plates are Eurasian plate, African plate, Indo-Australian plate, North American plate, South American plate, Pacific plate, and Antarctic plate. And the minor plates are Caribbean plate, Cocos plate, Nazca plate, Arabian plate, Philippines plate, Juan de Fuca plate, and Scotia plate. And you can see the crust density. The density of the crust is very lighter, while the density of the crust of ocean is heavier because of the presence of different materials. Oceanic plate composed of Cl and magnesium, while the material constitutes the continental plate are silicon and aluminium. These are lighter. You can see here the position of different continents and the different geological period. And it took a lot of years to take the present shape of the continents and the distribution of continents and ocean. This is the world map. You can see the different plates of the earth. The major plates are North American plate, South American plate, African plate, Eurasian plate, Indo-Australian plate, Pacific plate, and Antarctic plate. Some minor plates given here are Cocos plate that lies between Central America. Cocos plate lies between Central America on the eastern side and the Pacific plate on the western side, and the Nazca plate which lies between Pacific plate and the western uh, Pacific plate and South American plate. You can see here the Arabian plate which lies on the northeastern part of African plate. Another minor plate is Philippines plate. Here it lies in between Eurasian plate and Pacific plate. Just southeast of Philippines plate lies the Caroline plate. There are three plate boundaries recognized under plate tectonic theory. These three plate boundaries are divergent plate boundary, second one is convergent plate boundary, and third one is transform plate boundary. In divergent plate boundary, you can see here two plates are moving apart from each other, and the gap occurs in between the two plates that is filled by the magma inside the magma chamber that are filled by lava. When the magma comes to the surface is known as lava, and that gap is filled by lavas and creates the formation of new earth crust. And the second one is convergent plate boundary, when the two plates are moving towards each other. When the two plates are moving towards each other, one plate is subducted beneath the another plate. That is, one plate is buried beneath the another plate. This leads to the destruction of one plate which moved inside the another plate. And the third one is transform plate boundary. Here the two plates are sliding past each other, neither creating any earth surface or neither creating any earth or not destructing the earth. We will study all these three plate boundaries separately. First one is divergent plate boundary. You can see here most of the divergent plate boundaries are occurring in between the ocean. You can see here mid-ocean ridges are the result of divergence of the two oceanic plates. Here you can see through another diagram, you can see the spreading ridges. The spreading ridges are formed when the two plates are moving apart, and that gaps are filled by the hot and molten lava which are outpouring from the asthenosphere. Here new earths are formed. Here new earth has formed. Next one is the rift valley. When the two continent plates are pulled apart or moving apart, they form the rift valleys. The gap is termed as rift valley. You can see here in India, the Narmada and Tapi river flows through rift valley. When the two continental plates pull apart, they form the rift valley. Here you can see the best example of the African plates and the Arabian plates. In the prehistoric times, these two separated plates were once joined together. Because of divergence plate boundaries in between African plate and urban plate, they were separated, and the gaps are filled by Red Sea. You can see here, and the gap are filled by Red Sea. Now we will come to the convergent plate boundary. The convergent plate boundaries are of two types. When two plates, one is continental plate, second one is oceanic plates, are colliding. This leads to the formation of subduction zone. The oceanic plates, which are heavier in density, subduct inside the continental plate, and the trench are formed along the line of subduction. The second one is when the oceanic plates, when the both plates of oceans are colliding, then there is a volcanic islands. There is a volcanic islands forms. Third one is when the two continental plate collide each other, that leads to the formation of alpine mountain system. Subduction zone. Subduction zones are those zones or those parts of the plate which consumed inside the another plate. You can see here Palo-Chiri Trench. When the oceanic plate collides with the continental plate, the heavier oceanic crust subducts beneath the continental crust, and the portion of the oceanic crust which are consumed under the oceanic plate are termed as the subducted zone, and along the subduction zone lies the trench. When the two plates, that is oceanic plates, colliding each other, that leads to the formation of island arc. You can see here island arc. When the two oceanic plates are colliding each other or converging each other, at the point of convergence, island arcs are formed. Now, the continent collision, when the two continental plates converging at the single place, leads to the formation of alpine mountain system. European Alps and the Himalayas are the example of continent collision. We have seen the volcanic arcs which are formed when the oceanic and continental cranes, when the oceanic and continental plates are converging, that leads to the subduction of oceanic plate, which results in the violent eruption of volcano, which leads to the formation of volcanic arcs. And some of the landforms associated with the convergent plate boundaries are when the continent and the oceanic collision zone, deep sea trench, volcanic arcs, andesite volcanic rocks, subduction zone, these all are formed. In the zone of oceanic versus oceanic collision, deep sea trenches are formed. Volcanic islands can be recognized. Basaltic volcanic rocks are also found here. And the zone of continent versus continent collision, where granitic rocks are found, mountain building processes are going on. These regions are not associated with volcanic activity or any magmatic activities. Now see the deep sea trench. These are formed when the oceanic and continental crust. Deep sea trenches are formed when the oceanic plate converges or striking continental plate. The heavier plate, that is oceanic plates, which are consumed inside the continental plate, deep sea trenches are formed at the place of subduction zone. Deep sea trenches are formed. These trenches are as deep as 10,000 meters. One such deepest trench of the world are Mariana Trench off the coast of Philippines. Volcanic island chains. When the two oceanic plates are colliding each other or converging each other, volcanic island chains can be formed. Mountains or alpine mountain system. These are formed when the two continental plates are colliding each other. And Himalayas are the such example which formed out of continental converging plate boundary. The third boundary, that is transform plate boundary, where two plates are sliding past each other. They are not creating any earth or not destructing any earth material. These are also called faults. This causes earthquakes, tsunamis on the oceans. And one such example of transform boundaries are San Andreas fault, which are found in the North America. San Andreas fault, you can see here, these two plates on the either sides are sliding past each other in the opposite direction. This doesn't result into creation of any earth material, nor it causing destruction of one plate at the expense of another, as in the case of convergent plate boundary. Some of the features associated with the transform boundaries are horizontal grinding motion, strike slip faulting, lateral offset of rock units. Now we are coming to the last segments of this chapter. This is the formation of Himalayas, and you know that Himalayas were formed when the two continental plates are converging at the single point. The bottom left side of the map, you can see here, the Indian plates are colliding the Eurasian plate. Here you can see in this map, there are different phases of geological time for the northward movement of Indian plates that are going to strike the Eurasian plate. The formation of Himalaya starts when the Indian plates that broke from the Pangea around 200 million years ago that drifted northward, and it tries to converge the Eurasian plate, and the Eurasian plate was stand still at its own place, but it was Indian plate that moved northward. Before they collide Eurasian plate, they have to confront the large geosyncline named Tethys Sea, and the large geosyncline are the deep basin area which are connected by numerous rivers. These numerous rivers discharge their waters in the geosyncline, carrying sediments along with the water. These sediments deposited and consolidates after a long period of time leads to the formation of sedimentary rocks. When the Indian plate moved towards Eurasian plate, it has to strike the geosyncline which squeezes the geosyncline and creates folding of the sedimentary rocks underlying the Tethys Sea. Due to continuous movement, northwardly movement of Indian plate leads to the formation of Himalayas, and the Himalayas are still rising because of Indian plates still are pushing northward. You can see here around 140 million years the position of India was around 50 degrees southern latitude, and around 60 million years ago the position of India was as close to the equator. When the India was moving towards Eurasian plate, that leads to the rupture on the surface of India, and the huge cracks and the ruptures that happen leads to the outpouring of lava, and that creates the Deccan trap. So we have completed the chapter. Hope you all have enjoyed getting the concept or basic concept of this chapter. Thank you. Bye.